in our series of e-commerce and problems in the AI space. Today with me is Piotr Kopczakowski, our Senior Principal Solution Architect, and myself, Jürgen Oppermann. I'm in charge of the EMEA, Asia Pacific and Japan region. And today we're going to talk about the personalization problem and how to kind of build a solution which works with today's requirements. And just housekeeping, if you have any questions, please feel free to send them to our email address, which you can find in the resources, and we will, in due course, answer them directly via email. Today, we're going to talk quickly about the introduction and what's the problem, stating the problem, and how one can actually effectively build a personalization engine in the context of that, the models, and how you can use e-commerce data to particularly use models to be more specific in the way you present those, how the ranking agent would work, real-time in action, how that actually works, what you are building. We show you a demo, and that's going to give you some inspiration on how you can actually build these systems. And then obviously, why would you use Vespa for this? And finally, the key takeaways. Now, next slide, please. When you think about what is actually the problem today and why personalization today fails shoppers, one of the major reasons is that many implementations have 24-hour batch cycles, which makes the data not very accurate, not very actual, and we call that stale data. The actual personalization is sort of one size fits all. It's by user groups rather than personal and individual behavior. So it's more like an aggregate behavior. And it's because of also implementation of fragmented systems where the actual search, the actual ranking, and the personalization are not combined, and not all the signals can be transferred from one side to the other. The result is that you get long lists of something you search for. If you say you want trousers, you get hundreds and thousands of trousers shown. You might not get the right size shown. You might not get the right color shown. And worst case, even products which are not even related to trousers. So this is where most of today's systems fail. Next slide, please. And if you see that is your problem and you wanted to fix that, there's a couple of ways you can actually do that. And the way you do that is basically by sort of a three-step approach you can use here. First of all, the best practice advice we can give here is that you should model all the data. The catalog data, behavior, content, context into a single representation of vectors, and put the metadata tensors and rank them all together. This is kind of the first step. What does that really mean? You take product attributes, embeddings, shopper profile, shopper history, business rules, and inventory, and put them into the same environment and build your models based on this information. And then also by capturing more signals in real time. What does that mean? If you look at what happens today, that products and shoppers, that changes every second. You know, people click, people use for different things. And with every click, dwell, return, and stock change, because you sold something and you put some new stock in, things will be changed. And if you can manage to put that into your model in milliseconds, would help to enhance the end user experience significantly. So take session intent as it happens, long-term taste and affiliations, and also the context from the query and device and location, the place where the person is going to be. So that will be step 2. Step 3 is only surface what matters to the customers. So use these singles at the query time to basically represent the data which is actually relevant and fresh, not yesterday's data from a batch job, and then rank that against the full picture with all the results for the shopper. So the search is ranked per shopper, not by a group of shoppers. Recommendations that actually fit the moment the shopper is there, and then merge these rules without breaking the relevance to the shopper with regards to the business needs you have. So if you kind of take these 3 steps and then think about how you could build the next generation of an efficient personalization engine. Next slide, please. Piotr will basically show you how exactly to do that, how to simple yet effective real-time personalization engine will be built. And he will take you through the steps you will see to have that. And in a demo, show you how that would look in real life. And with that, Piotr, please go ahead and take over.
Thank you again. So how this can be divided into really organized steps and how we create the personalization pipeline. So first of all, obviously we need to get product treatment and actually extract enough information for the product itself in order to be used in the system. So first of all, we'll use AI vision models. So there will be actually in our demo, you'll see that there are 2 different models. One is VLLM, which is doing product descriptions, extracting the different features, and then also doing the what normally humans will be doing, the organizing even some pieces of metadata. Then we extract product attributes, and product attributes will be represented here in 2 different ways. One will be a sparse representation where we have all the structured features and the weights extracted into sparse vector. And the other one is model, which is used to extract dense representation of the item, also covering all of these features, even including brands, shapes, colors, and any other aspect of the products. When we actually have these items represented that way, then every interaction of the user, every click, every add to basket or purchase can actually modify user personalized representation. So what does it mean? That every interaction with the item will create or transfer portion of that product information or item information into the user profile. The more user will interact with these items, the more data around these products will be embedded into user preference representation, sparse or dense, and then we'll be able to match these users with the items he would be more interested in, because we'll know what kind of features of the products he was actually more interested. Once we have this, we will score the products, which he will be looking, searching, or even on the category pages, which are relevant to him. So which are the closest representation of item to his vector, basically to the user vector. So how we model the data? So maybe I will start from really big thing in Vespa, which is the highly differentiator to other systems. So Vespa is not the vector database, it's a tensor platform where you can express any type of data, scalar, vector, matrix, or map of vectors in basically tensor representation. So everything will be tensor, and then mathematically will be performing the same operations. It doesn't matter what kind of tensor type we have. So what is important here, that we can represent any complex data modalities, representations, images, videos, maps, or and basically preserving the structure and vector representation or mathematical operations. We can integrate any type of model into our ranking expressions, so we can control any element in our data representation. So now, how the Vespa tensor engine is really organized. So the first important thing, that we have one format representation for any type of vectors. So we unify scalar vectors, matrices, maps, so we can do dot product against any of them. We can, when we have multi-level representation, so imagine that we have multiple categories, and then we do personalization into each category separately. So let's say we do personalization for, let's say, trousers, we do personalization for t-shirts, or maybe personalization for another aspect of the e-commerce platform, for example, even the cars or mobile phones. This can be represented in separate vectors, so user will not mix the features between those things, between those elements, and then will be able to separate them together. And this is again can be represented in a map of vectors, where the map and keyword for each vector will be actually category name, and then value representation is vector representation for the personalized view for this particular category. So we can integrate any type of model which can be represented in ONNX framework. So whatever you will find inside, for example, Hugging Face, or you develop on your own, which can be converted to ONNX, then Vespa can natively support it, and you can run inference in Vespa. And also, this is very important, that it will heavily eliminate the round-trip API calls latency between different separate inferencing platforms. So typically, I will just need to mention here that when you benchmark Vespa, you need to really look into the whole end-to-end solution, because Vespa is not just vector search, it's not just ranking, and all model inference is all together. And then when you combine all these elements into one single platform, then you heavily optimize the performance and latency across all of these components. And then in this kind of measurements, you'll see how big benefits you have using Vespa platform. So on top of it, obviously, ranking is heavy, big part of Vespa ecosystem. Ranking is enabling you to combine tensors, inference, and any mathematical operations to express any type of business logic or personalization, for example. And then when you think about these three features, then shipping any new feature, if this will be personalization, or maybe boosting some kind of, let's say, parameters of the products, but then keeping still personalization and business logic inside it, is super easy. So you just create new ranking profile inside the Vespa configurations, and in parallel to production traffic, you can test everything and then see how ranking models can be, how the ranking model is performing, and then you don't risk any performance degradation on the production system. Then when you are ready to ship it, then you just swap the ranking profile with new models, new logic, and then everything works in the milliseconds from the switching the ranking profile to the new one. So experimentation is super easy. So now it's very important, Jorgen already mentioned that the system works best if you model all your data. So everything which it can be shipped natively into the documents, this will be one of the, let's say, element of the signals which we use inside our ranking. So if this will be, let's say, representation, a semantic representation of title, description, or even chunk description of the, let's say, as a chunk representation of the description, or image embeddings, or maybe some kind of metadata like stock, rating, reviews, or anything like that. The more of this you can actually put here, then the more ranking complexities you can add, and then you can use all of those elements into ranking techniques, and then you can decide what kind of signals are the most important for you for your particular campaigns. The ranking engine. So how the ranking engine works in Vespa. So obviously we have basically a site where we need to provide some information to our ranking system. So obviously everything about the item, so price, reviews, recency, text match, quality. So any field which is represented or put into item, and then basically your catalog. So including also information derived from machine learning models. So image embeddings, text embeddings, or VLLM extracted features as well. So this is very important actually to put all of those information into catalog data. Then obviously every interaction, as we mentioned already, this will build the user preference, so-called taste tensor. It will keep the feature preferences accumulated from clicks or any other basically interactions with the systems. And those can be represented in both sparse and dense representations. So this is very similar to a very traditional approach of the two-tower recommendation system, where we build the models which will be representing embedding of the user, embedding of the products, and then we can match them and then find the closest between those two, and then those will be recommended items for that user. And of course, there is one more aspect that during the search, during the query, we can add also additional information through the query. So we can use some additional embeddings from the query to our system. We can put categories. We can put additional signals represented as a query parameters, which can be read later on in the ranking profiles. So now, when we have all this information passed, we have ranking profile. In ranking profiles, we combine all of these elements inside, let's say, common expressions. So we'll be able to look at the lexical side. So it's like keywords, keyword ranking, keyword scoring, then semantic similarity using the dot product calculation. Also personalization scoring, which is effectively dot product or distance calculation between user representations and then item representations. But obviously that personalized experience is not giving the guarantee for the seller to achieve the business goal. So obviously we need to mix it and merge it with the business rules. So let's say amongst the products which are relevant to the user, we need to actually find those which will be bringing, for example, the best revenue, or which will enable us to destock the high stock levels from our repository of the items, or basically apply any other, let's say, business logic which will keep users happy but also drive the business forward. So, and then in Vespa, every ranking decision, every element of, let's say, execution is basically can be represented in the tracing logs. So you can see exactly what happens and why this particular result was presented to the user. So in Vespa, you will be able to extract and then see every single process which resulted into particular answers. So what basically comes out from the ranking profiles? So mainly it will be important to understand that this is basically the ranking dictates how the products will be presented in your page. So we'll have the top most relevant items, personalized, and also aligned to the business objectives. So we are able also to extract features from the ranking profiles. So this is something like live generated data components. So every single function in Vespa will generate some data. This data can be created as the match, let's say match features, which will be seen in the output log. So if you like to use them, for example, for additional model training input, then you can actually use those functions to be exposed, and then you use this later on in the model training. So there is extensive information about this, how to train the model in our Vespa RAG blueprint. If you're actually interested more into how to use the ranking features, then please go there and then you'll see these details. And then going further, Vespa enables you to do to embed actually many things into one single Vespa query. So ranking parameters, and then multiple, let's say, vectors for vector searches. So you are not only enabled to use only single vector, but you can use multiple embeddings and multiple vector searches into one with the OR conditions, and then combined with the standard semantic and lexical search. So all of this makes it super simple and basically compacted way of doing the projects. So now, what does it mean real time in action? So how this will be working? So you'll see in this few seconds the demo. So we'll basically show you how we can create simple demo of putting things together. So we can use the user representation of the color tastes. We will put in our demo this representation of the colors, and then we'll see what kind of products will be based on that colors will appear on the screen. So now let's switch quickly to the demo, and then we'll go from there to actually show you nice output. So what you see here is what we mentioned already in the description. So we have products. Each product will have the VLLM generated content here. So this is description. As you can see here, we have different elements of metadata. And then we have also item features here presented as the key value pairs. And then the key is the feature, a visible feature, which is recognized by humans. And then the weight, how important that feature is to the product. So you see that our t-shirt, for example, is sleeveless because it doesn't have sleeves. It has a color. It has the flavor, let's say summer, mate, round neck, logo is visible. It has some floral, let's say component is low here. So what are the top graphic, sleeveless, cotton? So those will be the most important. So as we can see here, those are the real features of the item. And then when we look for similar products, we will see that we have either colors or shapes very much similar. And then for every item, we have the similar items actually found in the very, very similar styles and colors. And then what I need to mention that some people ask me, okay, so is it already the personalization? And then the answer will be that yes, because the match between similar products and then user end products is very much the same Vespa operation, is the dot product calculation, which is single line configuration in our ranking profile, which can be merged with other data. So now let's go to the exercise which we already mentioned. So then let's create this product, let's say preferences as you saw in the slide. So we'll say that we, for example, like green color, and then we'll say this is 5. And I will add green. I will add also yellow color. This will be 3. And then I will say that I don't like red. So I will just add the red, and the red will be -5. Now I will save it. Oh, sorry, I need to actually quickly log in once again. So yes, let's go once again here. And here we see the user profile. So let's add our preferences to see how our preferences will influence the view of the personalized page. So let's focus on the colors because colors will be easy to represent in our system. So I will put green will be 5, then yellow will be 3, and then maybe I don't like red, so red will be -5. We'll save it. Now we'll go to the front page, and what we see here, that the colors I liked, those are the major colors which we see in the product base, and then this is fully personalized to my color preferences. But let's actually now clean it, and then we'll go and then see how we can look at different, let's say, perspective. So we'll go and then look for gold shoes. And then I tend to actually compare this kind of behavior, which you'll see here, to the TikTok, and then how the modern media is adjusting the content to you. So as you remember, we have our personalization, we have our buttons here to simulate signals from the user. So I will just click maybe a few times here to quickly show you the results, and then you'll see that after just a few clicks, then we'll have personalization. When I click personalization sparse representation, that I clicked, and then now the products are updated. And then when I go actually to our front page update these clicks, now instead of the element which you saw before, you see this products. But then we can actually do one trick, and then as you remember, we got our colors, but now when I was clicking on these items, I see my personalization representation as the weights for each item. But if I modify black to, let's say, 5, I will save it. So you see my black is now 5, and I will go back to our page. This is looking like this, that every element actually of the previously seen page is basically adjusted to the black. And then what I also need to mention that many people ask us, okay, so what is the cold start? How the cold start problem is actually solved here? So this is a fully personalized view, and then basically you can basically see the results of this personalization just after a few clicks. So then I would say that the cold start problem is very minimal. So let's again clear our interactions here, and then I will show you now slightly different view, and then how the personalization will work on the dense representations. So let's actually go here. So maybe we'll start from by the way, this is just a text to image model. So the image representation of the view. And then maybe we'll show you first how the search is working here. So we'll be actually we'll show the search on earrings, for example. So we'll look for some earrings, and then now the model, when we look at the similar items, you see that similar items are found pretty accurately. So now if we look for earrings with animal, then we'll find the earrings with animals, different types of animals. So now if we go, for example, with parrot, we can actually see earrings with parrots, and then now we can navigate against those elements, and we can quickly adjust and then actually dive deeper into each element. So this will work for actually almost any type of the fashion elements, earrings with blue stone. So you see that search is working pretty amazingly good, and then also similar products are found very quickly. So now let's turn it into the more traditional and hard to find usually things from the descriptions if descriptions are not accurate. So we'll do trousers with hearts. And now we see that we have lots of different trousers, and many of them have actually hearts, and then even on the pictures where humans are there. And then typically for clip models, this is a problem when you have backgrounds, when you have people on that, it's much harder to actually embed those. But then with this approach, it works very well. So now what I will do, I will click a few times, maybe like this, maybe let me click this, maybe click this trousers, and then let's see how this was personalized. I just enable dense personalization, and then I see that what I clicked is already presented here. But we can obviously continue clicking, and then we'll see that if we click, then everything is reorganizing like in TikTok. The new refresh version of your page will be showing the products more and more towards your let's say preferences. And then this is really amazing how you can actually switch this to the and categorize that to different products, and you can build categories of these preferences, and then we'll be actually doing this that way. So now let's go back, and then let's summarize what we've been actually showing you. So let me actually go quickly, and then so why Vespa? So let's summarize all the things which you've been seeing today. So Vespa combines all these critical components into to build a modern system which will contain personalization, business logic, ranking, re-ranking at really high scale. So we have at Vespa typical things like search, let's say text search, lexical and semantic. So BM25 is lexical, ANN or KNN or sparse vector in single query, no separate vector databases, no orchestration layers, no re-ranking, and no personalization component outside of the system. So everything is built and then baked into one single platform. Vespa has also extremely efficient real-time writes, partial updates, so it can easily handle 100,000 or even more updates per second. So clusters can actually accommodate all of required signal, let's say, integrations into the platform without any problem. So many people are using, or many companies are using Vespa for feature stores because its configuration can be created in the way that everything will be stored in memory, so for fast read and writes. So the model inference happens on the nodes where the data resides. So it's collocated with the all informations which can be used for the inference. So no additional ETL, no external scoring. So it's really heavily visible when you have lots of items, and when you reach the numbers like billions of elements or items. Specifically, this is very typical for C2C platforms. And when you use more advanced models, let's say like uh, late interaction models, when you will have the per token embedding or more embeddings or more vectors basically per single item. And then when you need to apply more advanced functions, for example, maxim functions, which are typically very hard to do in other systems. In Vespa, you can do that where the, let's say, component resides, and you can obviously mix this with the business logic. So this is not just a single Copali model, which can be used for recognizing images or finding the contents of the text representations inside the PDF documents, but you can use these models to represent many other features, and then you can mix them with any type of ranking business logic. Vespa has a streaming mode, so Vespa can efficiently store really data per user per entity basis. So what does it mean? That if user has its own history or let's say interactions from the past, we can embed them into the streaming mode, and then it will be very efficiently stored on the storage, not in the memory, but when user actually starts interacting, this can be quickly loaded and searched, but per user basis. So we assume that user data is not very, let's say, vast and big, and then the searches will be only done within the user, let's say, bounded information. So then you can read more about streaming mode. In Vespa, it's heavily used for the modern system where you have, for example, AI or chatbot interactions recorded in that streaming mode. Transparent tensor, so we mentioned already a lot about this. So tensor support in Vespa is really good here because tensors can represent features or embeddings. They can represent personalization components. They also can be used for storing counter data and then creating the metrics or calculating the metrics in one run. So basically, you can have a set of counters in one tensor, then set of counters in second tensor, then you can divide or do any other operations on the full tensor in just a minimal effort for the CPU because it will be using SIMD operations inside our framework. So these tensors will be very efficient. And then also important to mention here that the partial updates which I mentioned before, they apply also for tensors. So you can modify each cell, each dimension of the tensor separately in partial updates. So tensors will be effectively very nice to store your metrics. And then obviously the most important for A/B testing, for evaluating for evolution and building a platform is ability to hot swap rank profiles. So you can have a number of ranking profiles, which will be different versions of your logic, and then you can test them in basically seconds. So you can run your system in production. You can create your rank profile, which will be test rank profile. You can test the queries on the live nodes and then see how this will be performing with even the live user profiles. Then if you like to do A/B testing, it will be very efficient as well. So with that, I will let Jürgen to mention about the takeaways, and then Jürgen, so maybe you can continue now.
Yeah, thanks, Piotr. Thanks for the comprehensive demo and everything. Yeah, what are the key takeaways here? Well, the generic personalization, as we described before, is going to cost you. It's based on stale batch signals and one-size-fits-all recommendations. What does it mean? It will decay the relevance, obviously, with the session, and the click-through rates will fall, and the overall revenue will fall, and you will make less money. And obviously, another side effect will be that the loyalty will actually weaken, and people will not come back to your site. Sparse tensors make the intent readable. This is actually a very important point, and you saw in Piotr's presentations how important it can be. So unlike dense vector embeddings, named feature dimensions are actually very human readable. Color, black in a certain ranking number, styles, minimal, and another ranking parameter in there. They are human readable. You can actually debug them, and they're directly updatable. There's no retrain of models necessary, no pipelining necessary. So sparse tensors are definitely will make your life much easier. They also going with something like the Vespa solution will enable you to create what we call a real-time architecture. That's the choice you have here, because with 100,000 writes per second and per node, that means that you can actually take all your signals, clicks, favorites, filters, removals into each ranking in milliseconds, ranking decision in milliseconds, not just the next day or waiting for the next batch to roll out. And then last but not least, it's also very important to have the idea that we are one platform. Not 5 various services where you lose information in between and create unnecessary latency. So retrieval, machine learning interference, personalization, merchandising control, stock levels, and so on and so forth are all run inside Vespa, and they're all co-located with the index. So there is no ETL, there's no separate scoring service necessary. It's all done in one system without losing information and without unnecessary latency in the process. So leaving you with that, I would like to, next slide. Thank you very much. So thanks for your attention today. Again, if you have any questions, please send them to webinar@vespa.ai. We will promise to answer them as soon as we can. And maybe one more housekeeping information. The next webinar in this series is on the 20th of May, and it will talk more about the signal integration problem at the time. So with that, thank you very much for all of you for listening to the webinar. Thank you, Piotr, for your presentation, and we're looking forward to see you next time in May, and also see all your questions by email. Thank you very much, and have a nice day. Goodbye.